All right, so today we're going to go into another part of the standard. We've been dealing with addition and subtraction of rational numbers, that's positive and negatives, decimals, and fractions. And today what we're going to do is we're going to start with multiplication and division of positive and negative numbers, and then we'll work on our way on to multiplication and division of um, decimals, multiplication and division of fractions, but they're going to be signed. And we have some background knowledge because we worked on this the first 3 weeks of school. All right, so let's look at the ways multiplication can be represented. Multiplication can be represented 3 ways, so I want you to know what it looks like. Okay, this is elementary with the time sign. They're using, it looks like an X, but it's really a time sign. But you will also see a little dot. A little dot in the middle also means multiplication. And it's not 3 ways, it's actually 4 ways. All right, also, you may just see a number mashed together with another number in instead of parentheses. That means multiplication. There's no space in between them. They're just mashed together. Now, you may see something like this. Whenever it has a number and a variable, when there's a number and a variable is just a letter, guys, and they'll just be mashed together. That means multiplication as well. Now, we don't want to just mash two numbers together because it'll look like another number. Suppose if I have 3 times 4, I don't want to just write it like that. I want to put the dot. Ooh, I want to put the times sign, okay? Ooh, I want to put the parentheses to indicate multiplication. But if you just mash a number together with another number, it's just going to look like 34. So to indicate multiplication between two numbers, we got to use a sign, okay? We got to use the dot, the times sign, or we got to use parentheses to indicate multiplication. Now, this is not multiplication because the 3 and the -4 are not mashed together. They're separated by a subtraction sign, okay? That's not multiplication. That's subtraction where you got to do direction, right and right. All right. So with all that being said, we're going to figure out what our rules are for multiplication and division. We know that for addition and subtraction, we just use says, same direction, add, different direction, subtract. Either it's left, left, add, right, right, add. If it's left and right or right and left, we subtract, okay? But that's for addition and subtraction. But multiplication and division, the rules are very different, okay? That's supposed to be subtraction. All right, so multiplication and division, we will not be using direction. We will not be using direction. Everybody get it? Won't do it. That's addition and subtraction. So we're going to start off with just what we know. And if you need a multiplication chart today, you can get your multiplication chart out. All right, here we go. We're going to start off what we know to develop some rules for multiplication and division. 5 times 5 is 25, okay? 5 times 4 is 20. 5 times 3 is 15. And I want you to notice something. I'm dealing with the 5s, but because these are staying the same, 5, 5, 5. But here I'm going from 5 to 4, 4 to 3, 3 to 2, 2 to 1. So I'm going down by 5 each time by the number I'm multiplying by. So instead of 5 times 3, the next one is 5 times 2, which is 10. You should notice something with your answer. Look at your answer. You're going from 25 to 20 to 15 to 10. 25, 20, 15, 10. You should know the next number is 5, okay? And without even looking at 5 times 0, we should know the next number is 0. 25, 20, 15, 10, 5, 0. Okay, let's look at a pattern, guys. Because now instead of 5 times 0, and let's look, 5, 4, 3, 2, 1, 0. Now we're going to go to the negative numbers. -1, -2, -3. We'll be multiplying by those. And we just think about what's on the number line. 5, 4, 3, 2, not that negative on there. We multiply by 1, we multiply by 0. Now we're at 5 times -1. So we just keep going down. But look at what happens to our answer. Look at your answer. Answer only. 25 to 20. Well, what did we do to get from 25 to 20? What did we do to get from 25 to 20? Minus 5. 25 minus 5 is 20. 20 minus 5 is 15. 15 minus 5 is 10. 10 minus 5 is 5. 5 minus 5 is 0. What is 0 minus 5? 0 minus 5. That's going to tell us what 5 times negative 1 is. So 0 doesn't go left or right. So you got 0, and then you have your left 5. You add 0, and you go left 5. Okay? So where does that put you? Well, it puts us at negative 5. Okay? Now we're looking at 5 times negative 2. Well, 5 times negative 2. Well, 5 times negative 1 is negative 5. What is 5 times negative 2? Well, just subtract 5 from negative 5. Because we're decreasing by 5. Decrease by 5 to get to the next one. So that goes left and that goes left. If you feel better rewriting this as subtraction, go ahead. Negative 5 plus, minus the plus 5 to negative 5. They both go left. That puts us at negative 10. Okay? Now, I know you can guess what the next one is. 5 times negative 3. Let me take these out. Everybody should be able to guess 5 times negative 3. So I'm going to go back. 25, 20, 15, 10, 5, 0, negative 5, negative 10. You probably can guess negative 15. Okay? So we see that. Let me get rid of all these. So now I'm going to take a look at what I have. If I can get rid of this. So let's just take a look at what I have. Just the signs. Look at signs on it. Five times 5. Well, both of those numbers was positive, okay? A positive times another positive gave us a positive 25. So it's pretty safe to say all your life you've been multiplying a positive times a positive, you get a positive. That's elementary, okay? This is elementary. You learned that in elementary school. 5 times 4. That's a positive times another positive. Positive 5 times positive 4. We get positive 20. Okay? All elementary. Now let's look at this. 5 times negative 1. That's a positive times some negative. Well, positive times a negative. That gave us negative 5. Okay? Gave us negative 5. When somebody's saying, well, does it matter about the bigger number or if it's more to the right or to the left? I don't care about direction if it's multiplication or division. You only concern yourself with direction on addition and subtraction. That is the only time you concern yourself with direction. Okay, now somebody said, okay, well, does it matter the order in which you multiply? You all, let me ask you this. If 2 times 3 is 6, then 3 times 2 is also 6. The order in which you multiply does not matter. So if 5 times negative 1 is negative 5, negative 1 times 5 is also negative 5. So a positive times a negative gives us a negative. But a negative times a positive is also a negative, guys. Keep in mind, that's positive, that's negative. Those are different signs. That's negative, that's positive. Those are different signs. Different signs, I got a negative. These were different, I got a negative. These were different, I got a negative. So it looks like if the signs are different, I get a negative. But we're going to keep going through and check things out. And you all, I need to make sure we understand what property this is. What property is this? I'm going to circle this. What property when I say 5 times negative 1 is negative 5, and then I switch it and say negative 5 times, negative 1 times 5, or 2 times 3 is 6, and 3 times 2 is also 6. If you switch the numbers around on multiplication or addition, that's called the commutative property. Commutative property, okay? The order in which you multiply doesn't matter. You're going to get the same answer. So if I did negative 3 times 2, I get, remember, keep in mind, a negative A negative times a positive is a negative. Okay, so it'd be negative 6. Or I could say 2 times negative 3, and I would still get negative 6, guys. It doesn't matter. So it looks like if the signs are different, the signs were different. Different signs here, a positive and negative, positive, negative, positive, negative. And remember, it doesn't matter if we switch these around. We can do that with the commutative property. It looks like if the signs are different, we end up with a negative answer, okay? That's what it looks like for multiplication. And again, the order in which you multiply doesn't matter. So I could have done negative 1 times 5, or negative 2 times 5, or negative 3 times 5. They just got different signs. Okay, let's take a look at, we'll just pick back up on what we have on this chart right here. 5 times negative 2. If I look in this chart, 5 times negative 2 was negative 10, okay? So now I'm focused on negative 2s. These are going down by 1, 5, 4, 3, 2. Okay, so let's see. Since we know if the signs are different, we get a negative. Positive times a negative is a negative. That's negative 8. 4 times 2 is 8. The signs are different. 3 times negative 2 is, 3 times 2 is 6. But the signs are different. That's positive, that's negative. We get a negative. Keep in mind, different signs from the first chart gives us a negative answer. We learned that from the first chart. 2 times negative 2. Well, 2 times 2 is 4, but that's positive 2 and negative 2. So the signs are different. We get a negative. Okay. 1 times 2 is 2, but the signs are different. That's 1 and negative 2, actually. The signs are different. That's a positive, that's a negative. We get a negative 2. And of course, we know 0 times anything, regardless of whether that thing is positive or negative, we still get a 0. Now let's take a look at the pattern. See what we're getting, okay? I'm going to erase this. Let's take a look at our pattern, see what we're getting, okay? All right, so we know a positive times a negative is a negative. But according to the commutative property, we could switch it around. A negative times a positive will also be a negative. Okay, so we're looking at 5 times negative 2 is negative 10. 4 times negative 2 is negative 8. 3 times negative 2 is negative 6. Let's look at our answer and see what the pattern is. Negative 10 to negative 8 is up by 2. Negative 8 to negative 6 is up by 2. Negative 6 to negative 4 is up by 2. Negative 4 to negative 2 means we went up by 2. And you can see that on a number line if you were to draw a number line. I'm just going to count by 2s. If I go from negative 10 to negative 8, I've gone up by 2. If I go from negative 8 to negative 6, excuse me. If I go from negative 8 to negative 6, negative 8 to negative 6, I've gone up by 2. Negative 6 to negative 4, I've gone up by 2. Negative 4 to negative 2, I've gone up by 2. Negative 2 to 0, I've gone up by 2. So what do you think the next number is? You're going up by 2. So go 0, go up 2, it puts you at 2. Okay? But this isn't a negative times a positive, or a positive times a negative. This is negative 1 times negative 2. I ended up with a positive 2. Okay. Well, let's see what happens. What do you think will happen if I do negative 2 times negative 4 times negative 2? The pattern should continue. 2 plus 2 is 4. Go up by 2. It puts us at 4. Okay. That was negative times another negative produced a positive 4. Okay, so if I go up by 2 again, I'm going to end up at 6. So that's negative 3 times negative 2 is a positive 6. Okay, so let's keep in mind, guys, what the signs are. Let's get the signs. Okay, here I had the signs were different. A positive times a negative or a negative times a positive, I got a negative, okay? But let's look at this. This is a negative, and that's a negative. Here, I got a negative times a negative equals a positive. And let's go back to elementary math. Elementary math was like 5 times 5, or 5 times 4, or 5 times 3. A positive times a positive equals a positive. Positive times a positive equals a positive. Positive times a positive equals a positive. So I'm going to write that back down. A positive times a positive equals some positive. Like 5 times 5 is positive 25. 5 times 4 is positive 20. 5 times 3 is positive 15. This is all elementary math, okay? That part. But it doesn't matter. Look, I'm going to group these two. Here this was a negative and that's a negative. I got a positive. Here there was a positive and that's a positive. My problems were both the numbers in the problem were both negative. Here the numbers in the problem were both positive. But when they were the same signs, when the numbers in the problem were both the same, I got a positive. Even if they were both positive, I got a positive. If the numbers in the problem were both negative, I still got a positive. But look up here, when the numbers in the problem were different signs, when the numbers in my problem had different signs, I got a negative. But when the numbers in my problem had the same sign, I got a positive. Those are the rules for multiplication and division, guys. So let's take a look. A positive times a negative ended up being a negative. Okay? So I'm going to go back. Let me erase this so you can see everything clearly. Just going to reiterate. Here, this was a positive times a negative, or a negative times a positive. We ended up with a negative. But what about a negative times a positive? Well, it doesn't matter whether you switch the signs around, because we said multiplication was commutative, guys. So you would still get a negative. What I'm telling you is if the signs are different when you multiply, I think I should spell that right. If the signs are different when you multiply, you're going to end up with some negative answer. So here we get negative 18. 6 times negative 3 is negative 18. Or you could use the commutative property and say negative 3 times 6 is also negative 18. All right, a negative times a negative gave us a positive. I talked to you about that right here. A negative times a negative is some positive. Or a positive times a positive, this was elementary. Elementary math, you learned this a long time ago, equals a positive. So in other words, if we're multiplying or dividing and the signs are the same, we end up with a positive, guys. Make sure you're pausing the video and taking good notes. So big ideas. A positive times a negative again is a negative. Make you write it again. A negative times a positive is a negative. Let me write it all the way out. These two signs in the beginning of the problem, the signs were different again, okay? They were different. We got a negative. That's negative 18. That's negative 18. I didn't mean to put this on here twice, guys. But since it's on here, let's just go ahead and rewrite it again. And that's the commutative property, which allows that you can switch the numbers around, but you'll still get the same answer when you multiply, okay? It also works for addition, but we're working on multiplication right now. Different signs gave us a negative. Here, a negative times a negative is a positive. A positive times a positive gave us a positive. So if the signs are the same in the problem, we end up with some positive, okay? Same, positive, different, negative, but that only works for multiplication and division. I'm going to show you why it works for division, guys. I'm going to go back and write same signs was POS, which stands for positive. Different signs is going to be negative, NEG, negative, okay? Why does it work for division? So you got to go all the way back to elementary school, like, I don't know, maybe second grade when they teach you, maybe third when they teach you fact families. So let's look. If 3 times 5 is 15, then 15 divided by 3 is 5, because if you take 15 and divide it by 3, it's going to give you this other number, which is 5. Or your numbers will stay in the family, guys. It's not like if 3 times 5 is 15 and then you start dividing with those same numbers, you're going to get a different number besides what's already in the problem. That's not going to happen. Or if you take negative 15 and divide it by 5, you're going to get the other number in the family, which is 3. So basically, whatever works for multiplication will also have to work for division because they're inverses of each other. The signs or the rules for multiplication and division are going to be the same. Okay? If I know that, and this is multiplication, I use parentheses, negative 3 times negative 8 is negative 24 because they're different. The numbers in my problem have different signs, so I end up with a negative. Then if I take negative 24 and divide it by 8, it's going to give me the other number in my family, which is negative 3. There you go. Or if I take negative 24 and divide it by negative 3, it's going to give me the other number in my family, which is positive 8. There you go. So you should be able to see that the rules hold true. A positive divided by a positive is a positive. Positive divided by a positive is a positive. Okay? These are the same signs. These numbers in the problem are the same. My answer is a positive. These numbers in my problem are the same. My answer is a positive. Look at the numbers in my problem here. Got a negative and a positive. These numbers have different signs. My answer is negative. These numbers in my problem have the same sign though. They have the same sign. My answer is positive. So the rules for multiplication are the same. Well, your rules for division are the same as the rules for multiplication. Same signs, you end up with a positive answer. Different signs, you'll end up with a negative answer. Okay, let's keep going a little. Let's do a little more. So what if I have negative 4 times negative 9 times negative 4? I get positive 36. That's multiplication. Same. I got a positive. But it should work the same for division because they're in the same family and their multiplication and division are inverses of each other. So the rules for one are the same as the rules for the other. That's why addition and subtraction both work with direction because they're inverses of each other. All right, so negative 36. If I take negative 36 and divide it by the negative 9, if I take positive 36 and divide it by negative 9, it's going to give me the other number in my family, which is negative 4. But look, these signs in the problem were different. We ended up with a negative answer. If I take 36 and divide it by negative 4, I'm going to end up with the other part of my family, the other number in my family, which is negative 9. These signs are different. I end up with a negative answer. So the rules hold the same. Same signs in the problem, you get a positive answer. Same signs in the problem, you get a positive answer. Different signs in your problem, you get a negative answer. And you can see that from those examples. All right, so I'm not going to make you write these again. Well, we might as well go ahead. A positive divided by, because this is division, it's the same thing. A positive divided by a negative is a negative because the rules hold true for multiplication. and for division. So these were different. We got a negative. Different signs, we got a negative. These are different. I'm going to end up with a negative. It doesn't matter whether it's a positive divided by a negative or whether it's a negative divided by a positive. They're still different signs. So we end up with a negative. A negative divided by a negative, well, these are the same signs. We end up with some positive. Positive divided by positive, well, you learned it in elementary school. It's just some positive, guys. Okay? All right, if you forget same signs positive, different signs negative with multiplication and division, there's so many other little strategies you can use. I'm going to show you the tic-tac-toe chart. The tic-tac-toe chart, according to this chart, you have a diagonal that goes left to right of all positives. So I got all positives, but if you'll look in my chart, you have that I can look at it this way. A negative times a negative is a positive. Or I can say a positive times a negative gives me a negative. Or I can look at it this way. It doesn't matter which way you look at it. I can say a negative times a positive is a negative. Or I can go here and say a negative times a negative is a positive. But you just got to remember that this has to be all positives and the rest of them are negatives. So if you're doing your tic-tac-toe chart, it looks like this. Filling all positives here and the rest of these are negative. If you're doing it on your own, you can say a negative times a negative is a positive. You could say a positive times a positive is a positive. You just use the tic-tac-toe chart if you forget your rules. All right, I was going to show you a video on multiplying 3 or more integers. What I'm going to do is I'm going to put a link in that goes over this rule, and you watch the link. Let me see if I can play it now. Come on in and sit down. I'm making a video. Let me see if I can play this link for you. 7 8 has 2 notes. This is called even odd rule. It also helps if you forget your integer rules for multiplication and division. And it's just 2 minutes.
When multiplying 3 or more integers, we have 2 options. We can just use the rules for multiplying 2 integers and then just multiply 2 integers at a time, or we can use the shortcut, or we can use a shortcut to determine the sign of the product. The product of an odd number of negatives is always negative, and the product of an even number of negatives is always positive. So looking at this first example, we have 1, 2 negatives, and 2 is even. Therefore, the product has to be positive. Once we know the sign of the product, we can just multiply, ignoring the signs. So 4 times 6 would be 24, times 2 would be 48, and again, we know it has to be positive 48. Again, the other option, just to verify this, would be to follow the rules for multiplying 2 integers, and then multiply from left to right 2 integers at a time. So negative 4 times positive 6 would be negative 24. And then we'd have negative 24 times negative 2, which of course would be positive 48. Looking at the second example, we have 1, 2, 3 negatives, and since 3 is odd, the product has to be negative. Then again, once we know the sign of the product, we can just multiply ignoring the signs. So 7 times 3 would be 21, times 2 would be 42, times 4 would be 168. So the product is negative 168. And again, just to compare, positive 7 times negative 3 would be negative 21. And then negative 21 times negative 2 would be positive 42. And then lastly, we have positive 42 times negative 4, which of course is negative 168. So whichever method you want to use, you'll get the right sign for the product.
All right, with that being said, let's take a look at a few, guys. I'm also going to show you one other thing. It's called a smiley face. Well, this said if you have an odd number of negatives, you end up with a negative answer. And if you have an even number of negatives in your problem, you end up with some positive answer, okay? So some of you may not know what odd is. Odd is anything like that ends in 1, or it has a 1, 3, 5, 7, or 9, or it ends in one of those numbers. Okay, these are odd. Even is anything that ends or has a 0, 2, 4, 6, and 8. Those are even, okay? So if you see something like this, I have 1, 2, 3, 4 negatives. 4 is an even number, so my answer is going to be positive something. So you just multiply 3 times 4 is 12. 1 times 5 is 5, and 12 times 5 is 60. You know it's going to be positive. Or if you had something that looked like this, negative 5 times 4 times negative 3. Let me put another negative. That's 1, 2, 3 negatives. 3 is an odd number, so you're going to end up with some negative. And I could say 5 times 4 is 20. And 20 times that 3, that last 3 is 60. So I end up with negative 60. I'm also going to show you something called the smiley face, which is probably what I use a lot. These two are my negatives, and this nose is my positive. So if you use the smiley face, and I had negative 4 times 5, 4 is negative. I could cross out a negative. 5 is positive. I can cross out a positive. And whatever is left is your answer. It's the sign of your answer, so it's negative 20. Or if you had something that looks like this, negative 3 times negative 2. 3 is negative, cross out a negative. 2 is negative, cross out a negative. I'm left with a positive, so I know my answer is positive 6. Smiley face works on that. All right, let's go down. We're going to practice these. We'll do these together. These two signs are the same signs give you a positive when you multiply or divide. It's positive 21. This is not multiplication, nor is it division. There's a plus sign there. So this is simply direction. You got to go back to your direction. That's 19 to the right. Plus negative is to the left. So you would subtract and you would get negative 9 because it's more to the left than it is to the right. I just need you to know when to follow what rules, okay? All right. On number 3, this bar means divide. So that's a negative divided by a positive. Those are different signs. So I end up with some negative. I end up with negative 9. They're different. 4 is neither multiplication nor division. Vince, go ask Coach Thomas or Miss Thompson if she can take y'all to breakfast. It's neither negative nor positive, and it's not multiplication or division. So I'm going to follow the rules for direction. There's a minus sign in between. It's direction. So I know 15 is to the right. Minus negative is also to the right. So I add. Don't get multiplication division rules mixed up with addition and subtraction. It's 15 plus 17. So I end up with positive 32. It's all to the right. Okay, what do you do if the negative is neither with your numerator or denominator? Okay, if the negative is not with the numerator or denominator and you got a division bar, then you just keep the negative. Or you put the negative with the numerator and not with the denominator. Or you put it with the denominator but not with the numerator. But don't ever put it with both. You can't take this and write it with the numerator and the denominator. That's a no-no, okay? That's a no, don't do that. Good morning, Central High School. This is just a reminder that when you keep the negative or say these signs are different, and you get a negative. Please highlight your students that are going and send all forms back to the office so we can get everything kind of internet. Thank you and have a great day. Now, if this isn't working for you, use a smiley face. So I could go back to number 1. A negative times a negative is a positive. Or on number 3, if you can use a smiley face. Please don't use a smiley face if there's a plus or a minus in the middle. Please don't. That's direction. But here you got a negative 45 divided by a positive 5. It leaves you with a negative 9. On number 5, again, if the negative is with the division bar, then what you could do is put the negative with the numerator or with the denominator, but not, again, with both. That's a no-no. Here, you could use a smiley face. That's multiplication when you got parentheses. Uh-huh. She's not. Thank you. Excuse me. All right, so that's positive 12 times negative 8. It's got parentheses, leaves you with a negative. Or you could say these signs are different. Different signs when you multiply and divide, you get a negative. And then 12 times 8 is 96. Be careful on 7, because on 7, you got a minus sign in the middle, so we got to go back to direction. Again, if you have a minus or a plus in the middle of your two numbers, go back to direction. That's to the left, and that's to the left. Now, if you need to rewrite this in its direction, it's negative 83 plus negative 31. And we will add those. That's negative 114 because it's all to the left. All right, this bar again means the division. That's a division bar. But the signs are different. So different signs produces a negative. Okay, now be careful. If you get confused, just use the smiley face or the tic-tac-toe, or you can say, well, I got one negative. That's an odd number of negatives. It's negative. Or you can say positive 40 divided by negative 8 leaves me with negative, and it's negative 5. 40 divided by 8 is 5. All right, when I have more than 2 integers, I like to use the even odd rule. I have 3 negatives in number 9. 3 is odd. So I know my answer is going to be negative something, okay? So I'm just going to start off with 5 times 4 is 20, and 20 times that last one is 20. So I end it with negative 20. Here I have 2 negatives in the problem. 2 is an even number. So I know my answer is going to be positive. Well, I just multiply 6 times 1. 6 times 1 is 6. Then I just multiply by that last 10. 10 times 6 is 60, so it's positive 60. All right, on number 11, you got to be careful. 0, it has a 0. Anytime it has 0 in it, the answer is going to be 0 or undefined. If 0 is on top of the bar of any other number, you're going to end up with 0. If 0 is under the bar, you got some number on the top and you have 0 under the bar, you're going to end up with no answer. You can't take a group of something and divide it into nothing, like 0 groups. 0 groups doesn't exist. So that's what we call undefined. Let me write this where you can read it. It's undefined, which means your answer doesn't exist, okay? Because you can't take a group of 5 people and put them into 0 groups. This means 0 groups. 0 groups doesn't exist, guys, okay? All right, so I can take nothing and divide it into groups, so the answer is just nothing. But I can't take 2 and divide it by 0. The answer is undefined. And the way I get my students to remember that is because if 0 is under the bar, I simply get undefined. You can remember that because under starts with UNDE and undefined starts with UNDE. That's the way to remember which one is 0 and which one is undefined. All right, you're going to pause the video and try these. Or how about we just do this for homework, okay? Yeah, let's make this your homework. Your homework is going to be complete 1 through 14, guys. That's all I want, complete 1 through 14. And it's going to be printed on your paper. And we'll check these tomorrow. Be careful. Like number 2 has a plus sign, so go back to direction. Number 4 has a minus sign, so go back to direction for me, okay? All right, homework 1 through 14. And I'll make a separate spot on Google Classroom where you can attach it if you just keep it on paper. Just keep it on paper, 1 through 14. All right. Thank you.